Welcome back, everyone. Okay, today we are taking on a total mathematical monster. It's the kind of problem that genuinely makes you want to pull your hair out. The complex trinomial. You know exactly the ones I'm talking about. The numbers are huge, nothing seems to fit, and honestly, the panic just instantly sets in. But hey, don't sweat it. In this explainer, we're going to conquer this beast together. We are literally building a foolproof playbook to turn this nightmare into a fast, systematic, and completely repeatable process. So let's jump in. We've all been stuck there, right? Staring blankly at an equation, trying to guess and check. Erasing, rewriting, guessing again. It's super frustrating. And honestly, when you're staring down a ticking clock on a test, guess and check is basically a recipe for an anxiety attack. Well, guess what? You can throw that trial and error method right out the window. Today, I am giving you a rapid-fire strategy that works every single time. We are swapping out that test anxiety for pure confidence. So here's our game plan for the explainer today. 1. The trinomial hard case. 2. Mastering the AC method. 3. Factoring by grouping. 4. The box method trick. And 5. Factoring in 60 seconds.
All right, let's kick things off with Section 1, the trinomial hard case.
Okay, let's compare two scenarios. First, you have the easy case. This is your standard quadratic equation where the leading coefficient, that little a right in front of the x squared, is just an invisible 1. Usually, you just find two numbers that multiply to c and add to b, right? Super simple. But then we have the hard case. This is where a is not a 1. It might be a 2, a 5, maybe even a 16. That one little number changes the whole ballgame. It makes the standard guessing method a total mess.
So, here is absolutely the most crucial thing to remember today. Before you run any complicated plays, you always do a pregame warm-up. Always. And for factoring, that warm-up means checking for a greatest common factor, or GCF. Ask yourself, can every single term in this equation be divided by the exact same number? Or hey, is there a negative leading coefficient we can just pull right out of there? You literally have to check this before doing anything else.
And here's exactly why that GCF warm-up is a total lifesaver. Imagine an equation like 16x cubed plus 12x squared minus 10x. Just looking at those numbers is intimidating. But wait a second. Every single term is even, and every term has an x. So if we factor out a 2x, look at what happens. The equation shrinks right down to 8x squared plus 6x minus 5. Just by pulling out that one GCF, we instantly scaled the numbers down. It makes the rest of the problem so much easier to handle.
Moving right along to Section 2, mastering the AC method. Now, using the AC method for factoring is basically our secret weapon. Let's break down the core algorithm. It's called the AC method because your very first step is to multiply your A value, the first number, by your C value, the last number. Step 2, take that brand new product and find a magic pair of numbers that add up perfectly to your B value, the middle number. And then step 3, you use that magic pair to split your middle term into two separate pieces.
Let's walk through a real example to make this stick. Say our equation is 2x squared plus 7x plus 5. Our a is 2 and our c is 5. We multiply them together. 2 times 5 is 10. That's our product. Now our b, the middle term, is 7. That's our target sum. So here's the puzzle. What two numbers multiply to 10 and add to 7? Well, it's 2 and 5. Those are our winning factors. We just cracked the code for this equation.
Up next, Section 3, factoring by grouping.
So remember that original equation, 2x squared plus 7x plus 5? We take that middle 7x and we literally split it apart, using our winning numbers, the 2 and 5. So it becomes 2x squared plus 2x plus 5x plus 5. Notice we haven't actually changed the value of the equation at all, right? 2x plus 5x is still 7x. But by splitting it, we now have 4 distinct terms. And that perfectly sets us up for grouping.
All right, here's how you execute the grouping. Step 1, put parentheses around the first two terms and another set around the last two terms. Boom, 2 groups. Step 2, look only at that first group and pull out its greatest common factor. Then do the exact same thing for the second group. And step 3, well, if you did the math right, a little bit of magic happens here. The binomial left inside the parentheses for both groups will be exactly identical. You just factor that identical binomial out to the front and you are completely done.
Let's see this in action on a slightly tougher problem. Say we have negative 3x squared plus 14x minus 8. Now, a pro tip from our sources, it's a really good idea to pull out a -1 right at the start. It just keeps all the math super clean. Once you do that, use the AC method to split the middle term, group your first two and last two terms, pull out those GCFs, and there it is. We get identical x minus 4 binomials. It just collapses beautifully right into the final answer.
Which brings us to section 4, the box method trick. Now, if you're a visual learner, you are going to absolutely love the box method. The beauty of it is that it uses the exact same AC math we just learned. But instead of writing everything out in these long algebraic strings, it organizes it into a really clean 2x2 visual grid. It is a total lifesaver for keeping track of your positive and negative signs.
Here is how you fill out that grid. Draw a 2x2 box. In the top left square, drop in your very first term. Bottom right square, drop in your constant, the last term. Now for the two empty boxes that are left, you just drop in those winning split middle terms you found using the AC method. Honestly, it doesn't even matter which one goes where. Finally, you just scan across the rows and up the columns to pull out the greatest common factor for each. And your final answer? You literally just read it right off the outside edges of the box. It is so slick.
All right, the final stretch. Section 5, factor in 60 seconds. We've learned the plays, and now it's time to see how using the AC method for factoring actually teaches you how to factor in 60 seconds flat.
Seriously, let's put 60 seconds on an imaginary shot clock right now. I'm going to prove to you that with this systematic approach, when you replace all that guessing with pure logic, you actually have plenty of time.
Before the clock starts, here is your rapid mental checklist to lock in. 1. GCF, if it's there, pull it out. 2. Multiply A times C. 3. Find the two factors that multiply to that product and add up to your middle sum, B. 4. Execute your grouping or your box method. And 5. Write out your final factors. That's it. 5 simple steps, 0 guessing.
Okay, let's run the play at full speed. Our equation is 12x squared plus 2x minus 4. Step 1, check for GCF. Yes, they're all even. Pull out a 2. We're left with 2 times the quantity 6x squared plus x minus 2. Step 2, AC method time. 6 times -2 is -12. Step 3, what multiplies to -12 and adds to our middle +1, +4, and -3. Step 4, split the middle term into 4x minus 3x and group them. Pull 2x from the first pair, pull -1 from the second pair. We get identical 3x plus 2 binomials. Step 5, write it out. Final answer is 2 times 2x minus 1 times 3x plus 2. Boom, stop the clock. Perfectly executed.
And just like that, you have completely crushed the complex trinomial. You went from staring blankly at a frustrating guessing game to executing a flawless, step-by-step mathematical strategy. So I challenge you. Take this playbook, apply it to your homework tonight, and just watch how fast you tear through those problems. Seriously, if you can beat this math monster today, what else are you ready to conquer next? Thanks for hanging out with me in this explainer. Keep practicing, and I'll catch you next time.